Hi, welcome to today's edition of Cracking the Cryptic, where we're going to deal with this Killer Sudoku, the deadly rated one from the Times on Saturday. Mark did the deadly rated one yesterday, but that I suspect is significantly easier than the one we're going to face today. So without further ado, let's take a look at it. Now, as usual, what I'll do is I'll fill in the obvious ones, just so that we have a start. So for example, this 16 has to be 7, 9 in some order. So noting things like that, I don't think there's anything terribly clever about that. And I'm going to try it more today and sort of hint at the next firm square that one should be able to fill in with logic. So for example, this square, well, this is a write-in, and I think in terms of improving everyone's Killer Sudoku skills, you should pause the video and try and work out why I think that's a write-in, and then again, that's a write-in. This square here is a write-in. So why do I think this? Well, firstly, let's look at the top row. We know this top row here adds to 45, and we know that the cages already appearing in this top row, they sum to 47. This 29, this 10, and this 8. So this cell must be the difference between 47 and 45, so it must be equal to 2 in order to ensure that this top row meets the condition of adding to 45. Now 8 in 3 cells can be done two ways, but once there's a 2 in there, only with the 1 and the 5 is that's the only option. And in fact, if we scan across using simple Sudoku rules, we can now see that this 7, the 2 here, is locked into this position. So we should definitely make use of that. And now I said we could get this cell, and it's just an extrapolation of the method we've just used on the top row. But rather than doing it on rows now, we need to do it on columns, and rather than doing it on single columns, we need to do it on 2 columns. So if we look at columns 8 and 9 here, we can see that the cages that are appearing in columns 8 and 9 entirely sort of encompass these 2 columns, with the exception of this cell here, which sticks out in the 16 cage. So let's add these cages and see what we get to. So we've got 8, 18, 26, 35, 60, 79. So we know that these 2 cells must sum to 11 in order to ensure that columns 8 and 9 sum to 90, i.e. 2 lots of 45. Now if these 2 sum to 11, this has to be 5. So let's fill that in. Okay, now where else can I see something interesting? Well, I'm not saying that we can write in the values of this, but we can certainly narrow these down to 2 possibilities, these 2 cells here. Again, using exactly the same method we've been using, so pause the video if you need to. Otherwise, let's just take a look at what I'm thinking here. So we have a 16 cage here and a 13 cage here. They sum to 29, so we know these 2 cells sum to 16. Now the only way of making 16 in 2 cells in the same cage is like this. And that means these 2 cells have to sum to 4. And again, the only way of making 4 in the same orthogonal direction is with 1, 3, 1, 3. So there we go. Now that is also interesting, because let's take a quick look at this 9 cage. Now a 9 cage in 2 cells isn't usually the place to start, but here we have some interesting numbers already in this 3 by 3 box. We've already can eliminate 1, 8 as a possibility, we can eliminate 3, 6 as a possibility, and actually we can eliminate 2, 7 as a possibility as well, because there's a 7 down here. So we know that this is actually the 4, 5 variation of the 9 box. And we're left with having to put 2, 6 and 8 into these remaining cells. And in fact, this can't be an 8. We can immediately see that, because if this was an 8, these 3 cells here would have to add up to 5, and the absolute minimum 3 cells can add up to is 6. 1, 2 and 3 add up to 6. So this can't be an 8. So this is 2, 6. This is 2, 6, 8. This is 2, 6, 8. But we need to remember that the 8 is definitely appearing up here. There's another big cage here. 29 in 4 cells is one of those standard sums. A bit like 30 in 4 cells. It can only be made one way, so we should definitely write in the 5, 7, 8, 9 alternatives here, like that. And these two can't be 5 because of the 4, 5 here. So the 5 up here is appearing in one of these 3 cells, and it can't be in this top cell for 2 reasons. Firstly, that would make both of these cells 5 within the 10 cage, but also there's actually a 5 already because of the 1, 8 here. So the 5 is in one of these 2 positions, and I don't think we can quite eliminate. No, we can't tell yet. So we have to try and make a mental note. I'm not going to put the 5 notation into these cells because I think it gets confusing. But we try and remember that one of these 2 cells has to be a 5. And the next obvious thing we need to do, sorry, I just had my phone buzzing there. So you remember when we looked at this cell, we concluded something about the fact that this couldn't contain an 8. Now we need to use that logic again immediately. So have a think about how we can do that in order to fill in 2 more numbers, or 2 more possibilities at least, in that bottom row. So again, we know that the 8 has to be in the 16 box. It just cannot be in the 13 box here. So if it's in this box, then we need to fill these 2 squares with 3 and 8 somehow. 3, 8, 3, 8, like that. And now that's good because we've now isolated the value of this 13. So this 13 is 1, 2, 4, and 6 in some way. So in fact, let's just write that in so that we've recorded it for posterity. 1, 2, 4, 6, 1, 2, 4, 6. And again here we need to pay a bit of attention to this, because this cell can only be a 2 or a 6, which means the 1 and the 4 are locked into this bottom 3 box here. And that's not definitive, but it certainly eliminates one possibility for this 8 box in 2. 8 in two cells like this can be made in 3 different ways: 1, 7, 2, 6, and 3, 5. But in this puzzle now, this cannot be a 1, 7. It could be a 2, 6, but only in this order. And it could be a 3, 5. I think that's unrestricted. Okay, so that's, and again, the reason for noting this is you can see that we still haven't put a 7, 8 or a 9 in this bottom 3 box. And we're running out of spaces to put the 7, 8 and 9 into. And that might be helpful. It's not quite helpful yet, but it's not far off being helpful. But we can use a neat trick here in order to actually lock this box down. So I'm going to tell you that you need to use the technique we've been using on rows and columns, i.e. the fact that rows and columns must each individually add up to 45. You need to do it on 2 rows in this grid. So you need to use the fact that those 2 rows should sum to 90. And if you do that, you can learn exactly what the combination of these 4 cells is. So have a think. I'm going to show you now. So the unusual thing about this is we're actually going to use row 5 and row 6. And you can see that if we're careful, look carefully at rows 5 and row 6, these 4 cells stick out from rows 5 and row 6. And that means we can isolate the value of these. And given that we know that these 4 cells have to contain 7, 8, and 9, that's going to be extremely helpful. And in fact, in this case, it actually is definitive, because if we just run through this quickly, so we get 42, 42, 47, 67, 87, 88, 108, 120. So we get 120, which means these 4 cells here must sum to 30 in order to ensure that these here, where the cursor is, sum to 90. So if these sum to 30 in 4 cells, there's only one way of doing that, and that's 6, 7, 8, 9. So let's fill that in and see what that tells us. Well, it immediately tells us that we can't have the 6, 2 variation in the 8 box. We're looking at 3, 5 variation, which means that we can fill in this as a 5, this is a 4, and this is a 1, and this is a 3. And it also tells us that this is the only place that the 6 can go here, so we can eliminate 6 as a possibility in the 13 box. So that was it's quite a neat trick, I guess. I'm sure many of you spotted that more quickly than I did, but I think it's a nice piece of logic. Now, obviously, if there's a 6 here, there can't be a 6 here or here. So we're left with needing to put these 2 cells must sum to 10 in order to make this 20 cage work. But in doing that, we could have 1, 9 as a possibility. I think that's allowed. I can't see a reason why that's not allowed, except that that can't be the 1, it can't be the 9. Can't be 2, 8, because we've already got 2, 8 in the box. Can't be 3, 7, because we've already got a 3 down here, and it could be 4, 6, annoyingly, okay, but only in this variation, like that. I think that actually, nah, that's annoying. I was hoping that would we'd be able to eliminate down and leave that with 1 possibility, but we can't quite do that yet. Now, the next obvious step, I think, is we can work out the value of that cell. So again, try and think about how. Pause if you need to. I'm going to tell you, okay, we can make use of the simple Sudoku logic here. So we already have a 1 up here, and we have a 1 here. We don't quite know where they go yet, but we know that this is where the 1 is in row 1, and this is where the 1 is in row 2. That means the 1 in row 3 is in one of these 3 cells, and it can't be in the 11 box because we're not allowed to put 10 in the other box. So this is the 1. We can write that in. Okay, so can we use that? It's extremely likely that the 1 is in these 2, but we can't quite prove it yet. And something I might look at now, I'm not sure if it gets us anywhere, is let's have a look at this second row. So we've already got 7 locked into it, and we have a 20 cage here. So that's 27. That means the remaining 3 cells in this row have to add to 18 in order to make our 45 rule work. But you can see that there are some values of this cell here that are not possible. So, I mean, let's take an example. If this cell was reasonably small, let's say it was 3, then these 2 cells would have to add to 15 in order to make this 18 work. And that's going to break this 16 cage, because we couldn't then fill in any numbers here. So what can we say about that? Well, let's keep going with that logic. So 3 won't work, 4 won't work, 5, I don't think 5 is going to work either, is it? So that was going to be 13, 14, and that would make that a 2, so that doesn't work either. 6, 7, 8, 9 might all work. If it was 6, this would have to be a 3, which is possible. If it was 7, it would have to be a 4, I think, which is not possible. 8, make this 10, 11, this would have to be 5, which is possible. 9, this would be 6, which is also possible. So it's not actually got us much further. I was hoping that the presence of the 1, 2, 4 here might really limit this 3, 5, 6, but it hasn't done. But these are the sorts of things that we need to do in order to make sure we're not missing an easy bit of logic that's going to take us forward. Now, actually, I like this puzzle. This puzzle is not as straightforward as some of the ones we've had recently that have been labelled deadly. Something I've noticed now, which is quite an interesting spot, is the if we look at this box here and think about where we can place a 2, there are obviously only 2 possibilities. It can be either here or here. Now that has an implication for where we can place the 2 in this 3x3 box. And we can actually rule out the possibility of this cell containing a 2, because if this cell contained a 2, it's impossible then to place a 2 in the central box. Yeah, because this 2 here is taking out these 3 cells, and this cell here would take out these 3 cells. So we do know that there's a 2 in one of these 2 positions. It probably doesn't help us here, but one thing that's also worth noting is if you have a cage of size 4, like this 13 box here, that sums to 13, it must contain a 1. Yeah, and we can test that by thinking about the possibility of if it doesn't contain a 1, then we'd have to add 2, 3, 4, 5 as an absolute minimum, and they add to 14. So we know that one of these cells is a 1. Can we make any more out of that? I'm not sure that we can. Let's fill in the fact that we know there's a 1 in here. And therefore we know, because we've isolated that we've proved there is a 2 in this 13 box, we know that the remaining cells here have to add up to 10. And that is a little bit restricted by the 7, 8 and 9 here. But I don't think it's quite restricted enough. Yeah, because I mean the fact that we've already used the 1 and the 2 possibility means that there's only 2 valid ways now of making 10 within this box without using the 1 and the 2. We can't use them twice. So we could have 3, 7, that would be possible, but if that's the case, the 7 can't go in either of these positions. The 7 would have to be over here, and this would have to be a 3, and this would have to be a 3, or 4, 6. Now unfortunately 4, 6 is totally unrestricted, I think. So we can't tell. Anything more than that would be my contention at the moment, and obviously that's not going to be enough to eliminate down. Okay, so the next thing we need to look at is we need to use the fact that we did all that maths earlier to work out that this was 6, 7, 8 and 9. And we need to think about how we can use this fact again to tell us something about these cells. How can we do that? Well, 12 plus 20 plus 21 is 53. And therefore, once we take off the 30 from this, we know that these cells here sum to 23. We can then add perhaps a 7. It's a 7 or a 9 we need to add to our 23. Now if we add the 7, these 2 cells would then have to be 15 to make this cage, this total 3x3 box work. Well, that's impossible, because then that would be a 1. So this cannot be a 7, this has to be a 9, and this has to be a 7. And that's nice, but we can then take that a stage further, because we can say, okay, well, if we've now got 23 plus 9 is 32, plus what's left, 13, this has to be a 3 in order for this to work. And that then we can say, well, now I can eliminate the 3 possibilities from this cell. Now I had the 3's in here to cater for the 7, so we can delete the 7's here, and now we have isolated the value of the 13. We know this 13 box is now a 1, 2, 4, 6 variation, And we also know that there's a 2 in one of these two positions, because we need to place a 2 in this box, and it can't be here. So this is a 2. And in fact that means by simple Sudoku rules that this is a 2. So now we're starting to make a bit more progress again. And now I suspect we can force some more cells here. So let's have a look at the top of the grid now. Now we've got this 7. We're able to say something about the value of these two cells. Have a think about why I think that's the case. Okay, so let's look at this. We've got a 29 box and a 16 box. That sums to 45, plus the 7, plus this 7. That adds to 59. So we know that in order to make this box correct, these 4 cells here must add up to 14, because we need the 59 to be reduced back down to 45 again. And we already have a 1 and a 2 here. So we should make a mental note, these two cells have to sum to 11. And we're quite limited now in terms of what this cell can be, because we've got so much in column 4 already. It can only be a 7, 8 or a 9, I think. So that means if these two are summing to 11, that would make this 2, 3 and 4. Well, the 2 options ruled out already, so we can eliminate that. That means that there's a 9 here, so we only can eliminate 9 from these 2 cells. Is there anything stopping this being a 7 or a 3? 4? Oh yes, there is. There's a 3. So this is in fact a 4. This is a 7. Which means that this 10 box now can only be made in one way, and that's if it's 3, 7. And you can see we already have the 7 here, so this is a 3. Oh, sugar. I need to do that. This is a 3. This is a 7. Okay. Like that. Now I can tell you, you ought to be able to work out the value of this cell, so have a think about how to do that. Okay, you should, if your maths is getting the same as me, you should be getting that to be equal to a 3. Why? Well, let's look at this box again. We've got a 3, a 4, a 2, a 1 and a 7. They sum to 17. If I add this 11 in, I get 28. Now that means these two cells have to be equal to 17 in order to make this box add to 45. Now this cage is 20 altogether, therefore that's a 3. And that forces this to be a 3, so that forces this to be a 5. And the only way this 20 works now is if this is 8, 9, and it has to be in that order, and that makes this a 6. So I suspect now we have broken the puzzle in the sense that we've done all of the hard steps, but we'll just carry on just to satisfy ourselves. There is nothing more awkward, but I'd be surprised if there's anything as difficult as what we've had to do so far. Can't be a 9, 5. Okay, so now we have a 1, 5 locked here, which is nice. I don't think it's going to force anything particularly. We should remember this can only be 1, 4 and 6, I think, can't it? Yeah, so this is 1, 4, 6 in some order, which means this can't be a 6, this has to be a 5. Now, this 18 box, these two have to sum to 12, so 4, 8 is possible, but if this was a 9, this would be a 3, and that's impossible because of this 3 here. So this cannot be a 9, and that means the only place a 9 can go is here. And that's useful because we actually know there must be an 8. This must be an 8 because then we still need to place the 8 in here. So this is 9, 8, this is 1, this is 6, and this is 4. And yeah, this is starting to get good now. There we go. So this is a 5, 8, 4, 5, 1. So this is a 1. So let's carry on with this. 6, 7, 6, 7. Like that. Okay. Should we can fill this in? Can't be down here. 9. These can't be 8s. So everything's starting to eliminate down. We need 3, 6, 7, 9 in here, don't we? I think. Yeah. So these are 6s, this is 7, 9. Which means this is a 2. Stop here. I'm not talking much at the moment because there's not a great deal to say. I mean, we're just tidying up the last few bits of this now. It's very nearly done. Well, something mildly interesting, I suppose. If we look at column 3 now, we've actually got a hidden quadruple. We've got 6, 8, 9 here, 6, 7. 6, 7, 8, 9 and 7, 9. So those 4 cells in some order contain the numbers 6, 7, 8 and 9 exactly, which means the rest of the cells have to contain, the rest of the open cells have to contain the numbers 1, 2 and 4. So we should definitely know that. That might be useful. Well, in fact it is useful. This can't be a 1 or a 2, this has to be a 4, otherwise this 21 box doesn't work. So there we go, 4, which means this is an 8 and a 9, which means this is a 9 and this is an 8, which means this is a 6, and this is a 7, and this is a 6. Nice. This is an 8, and this is a 9. We've got to place 6, 7 here, don't we? So that must be a 6, and this must be a 7. So this has to be 1, 5. In order to make this work. It's only one way that can work, so we can't have the 2, 4 variation, which means that this is a 4. This is where I wish this type quicker on this software. Okay, we should. So this has to be 3. This has to be 5. This has to be 5. So error in the notation there that I put in. I don't think it matters. Okay. This is a 4. This is a 6. This is a 6. So this was a great puzzle today. I thought this was proper deadly. You know, it required a little bit of thought, quite a lot of maths today, quite a lot of using the geometry of the grid in order to make progress. So I hope this is helpful, and we'll see you again next time on Cracking the Cryptic.